Assalamu alaikum. My name is Ali Al Hinai. Thank you for Dr. Daniel that today invited me to speak about my interesting thing about composting. So this is actually composting and compost is very important topic that here maybe in Oman we don't have that much we can say factories or the people know about the compost. And today, already this I did it for the organic student last semester. It is called virtual field tour to Al Haradi Composting Factory. Last years, actually, that the students came to our site and look for all the facilities that we have it have them in our factory, and they get good knowledge about the compost. And Dr. Daniel, at this again this course, it will be also support this the composting or the compost knowledge to the students and can know about more about the compost. So today, this actually the presentation we did it before and prepared by me and Dr. and Engineer Hamoud Al Ghafri there in factory. Inshallah, in the future, if there, the pandemic, this is Corona pandemic finished, inshallah, we welcome you to come there to share our knowledge with you. So this is our presentation today. Inshallah, I hope to focus about the main things, and I hope to give you clear pictures about what we do there. So the history and objectives. The history of the composting factory there. We started to plan since 2009. We start to build the factory, and we brought the machineries that requested for the for the composting factory. You know that the idea came after looking for our the royal court affairs. We have farms. We have also the animal, different animals that we are belong to the royal court affairs, like camels. We have the horse. We have cows. So a lot of waste we have it. We have there in our site. Some people that time think why not to take these materials and recycle it to produce a very valuable, or we can say the compost can be again, converted from the waste to the compost. Can that the plant again, to grow? To add it to the soil. So that time we think to establish or to build the compost factory. So we started at the beginning 2010 in January, start to produce as you can say commercial or industrial product to that we are produce it for our departments first. And later on, we find there is more amount, we start to sell it or sell the compost to any people from outside to buy this compost to get benefit from use the organic one, because we are dealing with the product is called organic compost that already since 2010. We get organic certificate. Later on, inshallah, we'll explain to you or to show you what the regulation that we are follow. Here, this picture will give you what we do in our factory. Here, you can see this is a tractor with a loader in front. This is backside of tractor, maybe because the steam here, it is not clear. And this is compost. It's called compost. This is the tunnel. It is called Compost Turner. And this is the materials that we use. It is from different materials. It's a mixture of materials. Here we have cow manures. we have camel manure, we have horse manure, and we have green manure, and the hay from also different plant materials. Put it in the layers, and this is called windrow. This is called windrow, and this is the steam. You can see it here. Here is because the temperature, or the temperature here is very high at the beginning, around 65, more than 65, we can say. And the steam, this is the photo took in winter, because in winter little bit we can, at the morning we can see how the steam came from the the windrow. So we put these materials in layers, and inshallah we'll explain to you how we'll do it in later slides. So this is called composting, the process that turning, adding water, and so on, monitoring for that around 2 months or more. This process in the composting yard, it is called composting process, that all the microorganisms work here inside this pile or inside this windrow. This is called the windrow, as the the terminology. So the composting is the aerobically a natural process. It is natural process. We are not adding any inoculant here. We didn't add, or we don't add any inoculant, any microorganism, anything that just naturally came from the feedstock or from the inputs that we added here, and start to degrade the organic matter that we have it here. So to break down organic matter, we have here bacteria, actinomycete, fungi, and so on. Different microorganisms here work inside this pile. So to break down organic matter, and to make the humus and convert the organic element which is inside this kind of organic matter. For example, phosphorus inside organic matter, we break it to inorganic nitrogen, which is not available inside outside. So I mean, to convert organic nutrients to be inorganic, because the plants will absorb or will take inorganic form of the elements. So this is the process. This is the rule of the microorganism. The benefits: nutrient inputs made available to the plant. Already I said it. Destroy the pathogens and viable seeds. This is very important, because this material came from different source, from the agriculture waste, from the animal waste. So the temperature 65, maybe 70, sometimes we record it more than 75. So all this temperature, this is the thermo, or it's called thermophase, or which is the microorganism like high temperature. Many of the pathogen will destroy, and also the seed. I mean the grass. I mean the weed seeds also will destroy, and will find at the end will get fine compost without these types of the weeds. And here is stabilize the nutrients like humans. This is the final stage of the breaking down the microorganism organic matter. It is called humus. And the humus, it is very important also for the build up the humus inside the soil. We can read about the humus. It will be like a type of like spongy, absorb the nutrients, build up the soil structure, and also contains humic acid, humins, and so on. And also some nutrients inside the humus can later on deliver for the plants. During composting, what happens? Organic matter broken down and nutrients released. Anaerobic microflora replaced by the aerobic microflora. Because, as I said, we are dealing with the aerobic microorganism, and the benefits later on, inshallah, what the difference between them. But because we are using Compost Turner, we inject, we can say, or aerate this pile or this windrow with the oxygen. So we make the aerobic microorganism to thrive, to increase, to work. And this is the final product. This is the final product. It's called compost. is a stable product for composting, contain organic matter, humus, inorganic elements, and beneficial microorganism with earthy odor. There is a lot of also, maybe you can add it, the compost can suppressive for some pathogen because contain microorganisms, beneficial microorganism can destroy later on if you add it to your soil, because this beneficial microorganism will fight the harmful one. So a lot of literature conducted about this. What's the important or of the compost? It is encourage the plant growth and health, because provide the plant with a lot of nutrients, beneficial nutrients, beneficial microorganism, and that supports or enhance the health of the plant. Build up the humus content in the soil, maintain soil organic matter, because as you know, the organic matter is very important for the soil to build up. Maybe it is what's the difference between the humus or organic matter. Don't think about it will be that much different or make you confused, because humus is the last stage of breaking down of organic matter. Organic matter still, when you add it to the soil, still have to also the microorganisms start again to break down this organic matter, to release also the nutrients from it, which is maybe it is not full decompose in composting, but still process continue in the soil. So also the organic matter is important to build up structure of the soil, texture, structure, and add nutrients, make beneficial microorganism. So by adding the compost also improve the soil structure, more variable, stable crumbs, because will be less compaction with good aeration, reduce erosion and soil compaction, increase aeration and water holding capacity of soil, because adding organic matter will capture more water, helps to retain and gradually release plant nutrients. So the plants will get a good level of the nutrients for the plant. Promotes beneficial soil organism, because we are giving like stock or adding some new microorganism to the soil, which is maybe don't have it before. So this will be as the enrich the soil with this kind of microorganism. Here is the compare, we can say comparison of the windrows and the bit composting. This is the windrow and this is the bit. Windrow that we have it in our factory. We have put the material in windrow. Bit, this is the traditional way that our can say fathers, grandfathers put it in our farm, but by digging the hole or the bit inside their farm, and dumping all the materials that from farm or from the animals waste, put it in this bit. And this is when the bit it will be as anaerobic, and because difficult to turn, it's small scale, not uniform, because in the top layer is it is not degradable, we can say it is not decomposed, and the inside maybe there is also maybe because the damping a lot of material in the middle, there is still not decomposed uniform. And there is also harmful gases or the toxic substance like hydrogen sulfide, NO2, methane. All this is as the indicator for the anaerobic. And also there is a pathogen, because the temperature not reach that much, and also still the weed seeds available, and there is also bad or offensive odor, as an indicator for the anaerobic microorganisms there. Our target, or our what we have in our factory, we are dealing with windrow that is aerobic decomposition by as I said before, they are aerated. We are aerate the by the Compost Turner to give oxygen and start the aerobic to decompose the material. Easy to turn because we put it in the layers, put it in the top of we can say the soil, or to turn it. And we can large scale because our window will finish around for 60 days. So it is, like we can say it is as a commercial one. Uniform quality, the top one with the same, the middle and the bottom. So the quality will be, same. Any part of the compost will take, it will be uniform. There is no toxic substance, free of pathogen, and also from the weeds, seeds. No odor when finished, because the final one, the compost, it should be like, take the soil, earthy soil. It will be like, the soil, or like mushroom should be. There is no any odor. Here is the again between this is our this is called windrow, and this is the pit. This is from the top. You can see a lot of here is no moisture material, still dry, and keep it this one for more than 8 months. Here, for 2 months, we'll complete our composting process. In Al Haradi Compost Factory, we have two main things: site and equipment. The site, we have reception place. We put each material that daily come from the horse stables, from the cameras, and from the waste from the other place, for gardening waste or farm waste. We put it in different places, because we want to put these, the waste material or input material in separately different in the site. And we have, it's called pre-wetting pit, composting yard, which is the place we establish the windrow, drying yard, screening, saving, backing building, and product store. That we put the bags in the store. Here the main equipment that we have it in our factory. We have wheel loader, tractor with a front loader, compost turner, hammer mill. We put this for use it for if we have for example agriculture waste, we want to make it very small. Trommel screen or saving, packing plant. Inshallah, we'll show it to all of this in coming slides. Forklift and lab equipment. How for establishing windrow, the main things that we have out or to look about, because now we have different materials coming from. We have to mix all this material, not like just bringing and mixing. No, we have look first for this one. You can see and ratio carbon to nitrogen. You have to put it in mind when you apply with the compost or composting. In the composting process, you have to look for the carbon to nitrogen. Carbon, it is the source of energy for microorganism, and nitrogen for the protein synthesis. This one, it should be the ideal one, from 25 to 30. If this ratio 25 to 30 of carbon to 1, this is a part. It is called a part. That means how many part of carbon should be. This one refers as a 1. Nitrogen refers as the 1. 1 part of nitrogen, and this is from 25 to 30 part of carbon. This is the ideal one. And different materials that we have it. For example, if we look for the wood. For wood, maybe the carbon reach more than 300, 500, and so on. Nitrogen referred to as a 1. So when take the wood and try to decompose, it will not compose, because we can say the bonds of the carbon is very strong, and the microorganism cannot start to degrade. So for each materials that we have it in our factory, we have to study the CN ratio. And there is the green plant matter are referred to the nitrogen. carbon with the brown or woody plant matter, straw, mill branches, animal bedding. So this is, also for the manure, for each, for example, horse manure, camel manure, we have also CN ratio. Later on, inshallah, coming slides will show you how this, the different CN ratio with the different materials. Also, we add humus, clay to form humus complex. We add clay. We brought this clay dam from the dams nearby our site. The top layer of the in the dam. Every year we bring that clay from that.
Doctor,
Yes.
I have a question.
Yes.
What's the process to measure and approximate the CN ratio?
Now, this is, for each materials, we have to analyze the inputs. But most of these, materials are available in literature. For example, grass clip 20 or 15 to 20 to 1. The manure, horse manure, camel manure, cow manure, we did it in our lab and we get the nitrogen. CN ratio, I mean, for the carbon, and we have to look for the carbon and the organic matter and nitrogen. We divide organic matter we divide organic matter by 1.73, and later on we'll get carbon. We divide carbon on nitrogen, so we'll find the CN ratio for the manure. I mean, for the horse, for the cow, for the camels. Is it clear?
Yes, doctor. Thank you.
Here is our. We did it here in our analysis in our lab. It is called CN ratio for inputs. This is the cow manure. There is a variation, or there is a difference from time to time, depending on the feeding of this animal. But we took the average one. So, for example, cow manure 25 to 1. So still 25 with our rank. Horse litter, why we call it horse litter? Because most of this waste with the hay, this hay use it for the bedding, for the horse bedding. So most of this is the hay, but still contain around 20 to 30% of horse manure. We did also this analysis for this horse manure. We get it 30 to 1. Here is the camel manure, little bit 32 is more than 30, and to 1. Green matter 20% to 1. This is just to give you show. We use mostly we use most of the grass clipping. This for establish any windrow, we have to put the materials as in different layers, because horse litter we receive more horse litter from the horse stables. So and the CN ratio not that much. We use it 60% as from the total of the windrow, right? 45.6 cubic meter. We also the camel manure 10%, cow manure we use it 10%, green matter 10%, and soil 10, sometimes 5, sometimes 10, and the total should be 76 cubic meter for each windrow. I mean, in any line or any pile that is called windrow is 76 cubic meter. We have the total intake. CN ratio at the beginning of the process must be 31 to 1. Sometimes become goes up, and sometimes little bit 25. So there is a variation, but still the process composting going well. At the end, the compost from 15 to 20 it will be. I mean the finished compost. For establish windrow, we put the materials. We have two pre-wetting bits. Here's for the camel manure, and the other, you can see the back side there, or the far way there, in front of the wall. There's another bit. This for the camel, and that one for the horse manure. Why we put this materials here? Actually, this will we put the material. We add water to observe or to soak this material to observe as much as we can to add moisture, because most of these materials came dry, and when applied direct to our in the windrow, that we have to spend a lot of water. We add more water, and sometime because this material dry will maybe not gain that much water. So at least from 3 to 4 days, we add these materials. Here's the dimensions of windrow. This windrow, you can see it like this one. Half, we can say circle. The width 2.5 meter, the height 1.4 meter, and the length from this we can say from here in front of this tree will go to 50 meter. This is for at the beginning because we put it this one as a commercial one first, to produce as possible as we can to put it in the space to get the good our revenue from the composting, because this, you can see this, the volume now is a little bit 1.4, but after 2 months, after 1 month maybe we'll go to half, and after 2 months maybe we'll get a little you can say less than a half, because the materials decompose and the volume it will be compacted, so the materials will go down. Why put this dimension also? Because this at the beginning from 1 week to 4 weeks, this should be thermal process there, and when put the material like this, this material will gain much temperature to kill pathogen, to kill also the weed, and also to decompose organic matters that we have here. We put these materials that we showed to you before in the layers. For example, we put at the base dry horse litter. Later on, we can add camel manures. Add again the wet, we can say the horse manure, and put it in layers. Cow manures again, and the top we put, for example, here soil, and again cover it with the horse with horse manure litter. So we put it in layers that at least to put these materials later on to to uniform good the quality of the, and also to distribute the moisture, because we know we need the moisture inside the windrow to distribute inside the pile or the windrow in good level. Here is this another one of Compost Turner. Maybe at the beginning we saw the first picture. This is, we use it at after 1 month. The main tractor we use it. The main Compost Turner. Not this one. We use the AC at the beginning. You can see that the big tractor there with the AC. Here is the open tractor, and this one is just for the not the heavy. For the soft material, because this is after 1 month we use this machinery. It's called Compost Turner. It is not heavy duty machinery. The first one which you show it to you, it is that one is called Georgia. It is very heavy. We can say it is working the heavy materials. But we can give you just here to show you how the different parts of the machinery. We have this tunnel, and we have here is called drum with the tines like knives. There's a knife. This to turn the materials and to keep also the materials in same place. When you turn it, it is not going here or there. No, still keep the materials, in the same place when you turn it. And you can see there is the nozzles here, or the small parts here. This is for the inject water. From this we connect pipe, the pipe here, in this valve. The water, if we need water, especially in the beginning of the composting, the water comes from these small parts called water nozzle. At the beginning, it is not now. It is this is complete. Maybe this winter more than 1 month. At the beginning, it should be the moisture from 45 to 60% take. Because the organism need moisture. Maybe as you remember at the beginning, the materials we have, it is not like this, dark. It was a little bit yellow or brown. So this is maybe dark because start the microorganism to destroy or to decompose the materials. Here also, this is the process is very slow. Turning at 250 round per minute, the drum here, and the speed of tractor less than 300 meter per hour. So one windrow, which is 50 meter length, will take around 25 minutes at the beginning to just to turn 50 meter. Turning, here is we can say the schedule we have from first week to 8th week. So first week and second week, we water and turn and cover daily of the pile or the windrow. Third week to 4 weeks, the water and turn and cover every 3 days. The 3 days for water and turn, but still we have to cover it. 5th to 6th week, turn and cover every 5 days. Need to, for example, it depends on the record that, inshallah, to explain to you what the records that we use it to put all, to know how the situation or the environment or the condition of windrow. In 7 to 8 weeks, we turn it once to dry. That means turn it once just to keep the materials dry, to make it dry, and to make it ready for the mature and to dry it. Here is Compost Turner. It's called Compost Toptics cover. You can see these people, this the workers here, run this. That one, when I said to you, we have the tractor, big tractor here with the AC, and this is the machinery. This is a heavy. We are use it in most of our time. We use this kind of. It is from the Switzerland. It is usual, and it can work for heavy work. And you see how the machinery, the Compost Turner, the machinery, keep the materials uniform in the good shape in the same place, to keep it in the pile or windrow. We use this cover. This cover is called Toptics cover. Propylene. It is made from the polypropylene. Reduce loss of water to keep the water inside uniform, keep it in good level. Maintain, as I said, uniform moisture inside the windrow. That's the distribution of moisture inside this pile will be uniform. Allow gas to exchange. There is a small, we call it micro holes or pores there inside this pile to allow the gas come out from the windrow, and also to protect the windrow from outer or from the ambient temperature or ambient, like windy weather and so on, or rain, also to protect the windrow from the excess water. This is the most important, we can say, diagram to show you what the composting faces. We have three main phases. It is called, here we can show it as the initial state or initial or activation phase. It's called mesophilic, and we have thermophilic, and again we have mesophilic or mature. Mesophilic, from our experience, actually start more than around 30 degree to 45. So when we put the materials before turning, if we take the temperature record for the temperature, we found it more than 45. So we have mesophilic that start the special microorganism like this temperature temperature, and start after turning twice or 3 times or 4 times to jump to reach 65. As I said before, our temperature reach more than, we can say, around 75 or sometime more than that, because for many reasons. Maybe first of all, we have high temperature, and we have ideal, we can say, the CN ratio, and sometimes their delay. For example, if we have many windrows, if not follow the to monitoring the windrows daily, sometime the temperature reach like this level, or we can say like this degree of temperature. And this is the critical phase. I mean, why this is a critical? Here we can say to destroy the harmful or pathogen, destroy the the weeds, and high decompose of organic matter in this in thermophilic temperature, in thermophilic phase. And after this will take 3 to 4 weeks, and after that start from week 5, week 6 to the temperature goes down, because again the mesophilic microorganism start to work here again, until mature or maturation, that compost to be stable. There is the temperature, maybe we can say 30-35 degree or like this. So this is the we can say the layout, or the how can describe the microorganism works in composting. We have daily records for temperature from the 0 day, or from 1 day until to 60 days. So we have to record for the temperature. We have here record file, and we have also for the record for the CO2. We have 2 meters. It is called temperature meter and CO2 meter. CO2, it is not, we are not looking for the CO2, we are looking for the oxygen, how much the level of O2 inside our compost. But why we are using the CO2? Just to know how much CO2 inside our pile, and it should be not more than 12%. So we have probe here, and we have pipe. Here we have a liquid for the CO2, and this is the CO2 meter. We start to pump the air inside this probe for 18 or 16 times, and after that we put the meter up down and check the level, because the air will go inside this liquid and will give us the indicator. We use this this liquid for 300 readings, and we have to take 2 readings for each windrow, from the beginning and also from any part of the windrow, and we did it. I will take it as an average. We have to take 2 readings for each windrow. For the temperature, we have to take 2 readings for the CO2, and for each windrow we have to record at the history of the windrow from the beginning to in the end. And from this picture, you will see how many windrows we have here. For example, around 10 here. So if we put the composting yard in different area. This is, as far I remember, it is A area. We have around 70 windrows, so running in one time, and there is a variation. One maybe we establish now, and one maybe ready. We have to keep our factory to run. And you can see at the back of this photo, this is the building. There's the factory for the packing the compost. You can see the far at the back of the picture. And here, if you can see also, there is the thermal screen. So when this ready, I mean when the complete this one compost 60 days, we shift it to dry place there to make the moisture less than 20% of, and start to thermal screen to make it fine. And we have two options now. We can give it to the customer as the bulk without packing. That I mean that truck come to our site and we can load it, or we can take these materials to the packing machine there to packing for the bags. Put the compost inside bags. Each bag is a 20 kg. Before all of this, we have to take some, it is called quality insurance. I'll explain to you how can do approve for any compost. I mean, for any windrow that produced should be, we have to test it in lab for some parameters. Here is the quality insurance. We record the following during composting. So the composting from the first day of the windrow until we finish it, we have to look for the temperature, with the initial temperature from 55 to 65. At the end of the compost, soil temperature +5. For example, if the soil 25 degree, the temperature of the compost is 30. Moisture from the beginning from 45 to 60, but the end of the compost should be not more than 20. So CO2 less than 12% during the first week, and maybe after that from 12 to 15. Color should be from brown to dark brown. So you have seen it, I think. How's the dark? If you go back here, here this is still not fully decomposed, but if you look back here, start to to be dark color. There is no smell. It should be the the peat moss or mushroom smell or earthy, because the final product, we don't have ammonia or hydrogen sulfide. Hydrogen sulfide, when you smell the rot egg, if you have rotten egg, it will be bad smell. So no, we don't have any of these bad smells. Our compost is fine. There is, as I said, it's like mushroom and so on. Texture, we use it as less than 10 mm, because our thermal screen, we use it as 10 mm. The sieving, I mean, to make the fine compost. Also, we have analyzed the finished product, mature compost. We have two our analysis or quality control for divided for two. Any compost now ready, mature, before packing or before give it to the customer, we have to go for these. We can say for analyze or for the test the levels of these things. So the ammonium should be not more than 2 milligram per liter or 2 part per million. NO3 less than 300 part per million. NO2, this is a handful, it should be 0. Hydrogen sulfide should be 0. pH from 7 to 8. AC should be less than or equal 7. You know, this is we have variation here. Sometimes we record it from 3 to 7. Because you know this is deciments over meter, and we do the germination test to test how is it our compost harmful for the you know the plants or not. I'll show you how we can do it. And also we have chemical analysis. Chemical analysis, we have 3 labs. One belong to Royal Court Affairs, and other one for the Ministry of Agriculture, and the third one it is called private lab. So from time to time we send different samples for them to analysis. We do analysis for the organic matter, NPK, also for the micro, we can say macro and micro elements, and also for some time for the heavy metals. That's what, for example, as nickel and so on. Lead, different heavy metals that we have to check also for the level of this from time to time. We have here lab equipment. We have this is called quick test to show how our compost quality. We have the strip. We have some compost here. We add HCl. We have here is the strips as indicator for level of hydrogen sulfide. It will give us how the level of the hydrogen sulfide inside our compost. And we have ammonium for the quick test to get by chart here. If it we put it, this is the different reagents, and the color of the compost will give us at the end what's the level of it. And we have also nitrate, NO3, NO2 test. We have also for AC. Here is the we have it is called Spectrophotometer. We have around 12 elements, and we have caveats. For each element we have different caveats, and we put this is there is a procedure, a protocol to follow it, and we put the each of the testing element inside this spectrophotometer will give us the level of the element inside our compost. Here we have for the pH meter, we have different actually pH meter and for AC meter, just for to show you what equipment that we use it here. And also you can see this is one used for the test for the germination test. We take the mature compost, we put it in the jar, and we put the cress seed or radish seed. Totally, we give it a little bit to water and tight cover it. Not allow any air go inside. So we want to check the micro environment of our compost, how will it affect the quality of the growth of the for the plant, and we can say always we get good result. We get good germination with good rooting system for every time. And also we'll do for the weed germination. Here maybe we didn't give it to you. We do the weed germination to test do we have any weeds in our compost. Till now we didn't find any positive result. Positive result, we don't have any weeds germination. Here we can give you unpacking screen. This is the fine one, this is the waste one. For each we put the materials we have, it's called the trommel screen. By loader we put, there is the banker, big banker, receive the fine, or we can say the mature compost banker. We have two parts, one for the fine, we can see how the fine of our compost 10 mm, And this is the waste one. There is the gravels, ropes, plastic, and different materials that we have. Still some material don't decompose because maybe some woody woody branches and so on. So this is the waste. After that, we bring all the fine materials. We have to now. This is we have two thermal screen. One thermal screen direct join to our packing machine. We have conveyor built that transfer the fine compost direct to this machine. This is called PTH machine, which is to packing by thermal sealing. The materials comes from conveyor built, and the machine receive the materials, put it in the scale. I mean 20 kg, and start to the thermal sealing. And the bag also, there's a conveyor comes out, you can see, from this hole, and there is another conveyor built here to press the bag as a flat. You can see how the flat here to press the bag, and also to make holes here. First hole to make for two main things, or two more things, to make the air go inside to keep our compost as aerobic, and also to allow the conveyor, which is the press the bag, also to get out the air from, to make it as a flat. We put it like this. So we have screening, bagging in 28 liter or 20 kg, just because we use 20 kg more. The here like to use the kg, but this is the machine established as made for as a liter, because this is the volume here. Storing, best to use it within 1 month. Our recommendation to use it in 1 month, but we can keep it for more than 3 months. And we test it we keep our compost for 1 year. We produce some amount of, we keep some amount actually of bags, and every month we test the quality of compost. We test it for 1 month, 1 year, and we didn't find any significant result. The quality of compost didn't change. As I said before, we have organic certification. Our product, one inspector person comes every year to our site to check our factory, what we do there, and after that, we're looking for everything. For our documents, for our process, for our in the sites. Look, do we work with as he regulation that he asked us? We have two main regulation that we have to follow: 834/27 and 889/28, 2008. So all of these regulation we have to follow it, because there's a regulation you can go to later on to check. This is available on internet. So can you after that, after check for everything, inspect everything, he will give us certificate, because we are following the regulation or the rules. What are the factor affecting the compost process? The quality of compost, as I said before, CN ratio is the most important thing. Also the size of the particles. If the microorganism prefer to break down, to work in the small pieces. So if the particles, are we can say big size, so the composting will take longer. Turning frequency, because sometimes we have to follow to look monitoring our window, and daily we are look for you have to to check our windows daily. The condition of that, we have, if any day, for example, in holiday, because we are working 6 days a week, and sometimes, you know, for some circumstances having like holiday, or but still we have divide the people to work there. But sometimes, you know, in rain period, sometimes we have to stop because the area, it is not good for the machinery because we know we don't have the we can say concrete area, just, you know, in the top of soil, compacted soil. So sometimes when run the machinery on that area, especially in rain, you affect the ground. Moisture level, because, you know, the moisture is very important, and we have to keep moisture from 45 to 60, as I said before, because if the level of the moisture not reach that one, the microorganism don't thrive, don't work, and that's mean reproduce, or we can say increase their number to start to decompose. We have also machineries status. Sometimes, you know, that because this is machineries, heavy machineries, we have around 4 machineries. I mean 4 tractors, and we have also 4 compost turners. Sometimes, you know, because we have commercial scale, or we have to produce in good or amount, or a very high amount of the compost, you know, this machinery is sometimes affected, and we are running from here. We're asking the maintenance people to come, but sometimes the spare parts or the technician maybe are not available in that time. So we have in machineries problem. Challenge during composting plastic waste, because, you know, this is materials we brought it from different places, so we cannot manage that people to add or to give him restriction rule to follow it, because, you know, they came from different parts. We cannot manage them to stop adding plastic waste. We have also stones and also ropes, because, you know, we use the rhodes grass and bundles. That's for example, in horse stables, that the people there, we are fighting with them to don't put the ropes, because the ropes will affect the compost turner. That's, you know, that's the compost turners, you know. And also hardwood materials. Sometimes inside the materials, like woody materials, also this affect the drum or the compost turner. Here the recommendation, because as I said, we are organic compost, and you know, we put some recommendation for the customer how can use this our compost, but, you know, this is, we give it as the general recommendation, but any person can add more or less, depend on the soil condition to get benefit, for a good benefit from compost. So we can apply different level or different amount of compost as he as the soil or as he purpose. So we put the recommendation for vegetable, flower beds, lawn, trees, shrubs, potting substrate, sowing medium. Even for that, here, for example, for sowing, as a which can say as a growing media, our recommendation, we don't put more than from 20 bag of compost. We should mix with the peat moss, because, you know, still the compost with the high AC, because contains a lot of elements, comparing with the peat moss. Peat moss came from the, you know, acidic place or swamp with maybe the pH so low, is acidic, and, you know, or the peat moss doesn't contain that much of minerals, so that the AC is still less than, I think, 1. But in compost, as I said before, from 3 to 7, and this will be affect the growing, I mean, for the seedling. So our recommendation for the people to use, if they want to use the compost in the growing media, from 20 to 40%, and add it with the bitmos. Here I'm not going to give you explain about this slide, but we can see it later. This is a PDF about the how can you know, run or establish or make your compost at home. This is a PDF. This did it by the Cornell University, and there is some ways or different ways that use it. And you know, we can just give it here as example. Here is the YouTube also. YouTube for 6 ways give you also at home. You can do it your compost, and you can expand more in YouTube. You will find more than this one. So just, you know, to give you idea about composting. So this is my presentation. I hope that, you know, get the good picture about our composting factory. Thank you very much. And if you have any question, I am happy to answer it.
Thank you, Ali. You can stop sharing if you want, or come back to the slides. I will open the floor for the students to ask questions now. Any of the students want to ask? Rashida, your mic is on. You want to ask a question?
No.
Okay, I will start with some questions. If any of the students want to jump in, you're welcome. We will proceed up to maximum 9:50. Just this is the normal time for the class. But if you have to leave, you can watch the video later. Yeah. So what is the location of the compost site, Ali?
You mean the composting factory?
The wilayat.
Yes, it is not far from the university. It is in Barka.
Okay.
In Barka, it is around 20 to 25 minutes from the university.
Okay, so what is the relationship with the Royal Court Affairs? You were part of the Royal Court Affairs, or is an independent company subcontracted?
No, it is belong to the Royal Court Affairs, to D1. And you know, maybe I didn't say this before. Before we established the factory, Royal Court Affairs paid money for the companies to take this waste from our places to the dumping area or different purpose. Now, no, we are running our we're taking this waste by our vehicles to our site, and also to start to composting these materials and produce that compost. So the purpose of the objective of the factory to provide the farms, Royal Court, I mean the farms and gardens that belong to the Royal Court Affairs with this compost. This is the main purpose for the establishing the composting factory.
All right. Do you have a commercial name for the compost you sell? Because it's a commercial activity now. It's not only reused on the farms, but you are selling this compost also. What is the commercial name? And is there a web page, and where do you find this product?
Actually, unfortunately, that we asked His Majesty, who passed away, a lot of time to, you know, because this is under his properties, was under his properties. We asked him that time to give it a name and to give it, and later on when can run for the logo and give it as the, you know, commercial file or serial number for, you know, cancel it inside Oman, outside. But that Majesty that time he stopped that one. So still recently for 1 year now, we're running for the get this name again. With to give it the name for the factory as a commercial name, and also now our bag is without any printable. There is no prints. There is no description. Just a green bag. But inshallah, in future, maybe I don't know how long it will take, but nearby, inshallah, we'll give it name, and already we registered in the commercial, Ministry of Commercial and give it as a registration for. Inshallah, we'll get the name, inshallah, in future.
All right. What is the
But
total capacity of? Oh,
we
sorry.
don't have a website. We don't have website. Just anyone can contact us. Still, we don't have that.
All right. What is the total capacity of the compost factory? Input capacity and output capacity. It means how much material do you receive, and how much compost do you give away, or for the farms or sell it?
This is, Doctor, as this is very sensitive question.
Oh, okay. So it's
this is sorry for this, because still that we deal with Royal Court Affairs as any parts of Royal Court Affairs as a private sector, or private. Yes, it is belong to the government, but still there's some questions we cannot allow, or not. We don't have that authority to answer it. But we can give you estimate. We received around, we can say, trucks, 10 to 11 trucks daily from the different materials, from the for the camel, from the horse stables, and so on. That every day we are for the collecting this material for 7 days, and for the producing, we can give you estimate. We are producing many bags, 4,000.
It's okay.
That's mean we can say, what can I say? We have, we're covering a lot of our farms, gardenings, and even for the customer. We have, we don't have short take. We have more than that. We have, good quantities. We are as a commercial factory. But for the numbers, sorry for this, it is cannot answer.
Let me ask you another question. When you do the sifting of the compost at the end, you have the large particles. What do you do with that waste? Do you return it for recomposting, or what is it done with it?
Actually, that one we are looking for the particles. We can do twice again for the thermal screen, and when we get good fine again, we can start to deal it with the fine compost. If it not, we have to looking for for example, if for example wood chips a lot, we can use it as a mulch, especially for date palm. And for 3 or 4 years before, the farm in the Jabal Akhdar came to us, and they want this for the damping some places there in between the trees. In the Jabal Akhdar, there's a farm. There is a at the beginning of the farm, they put the trees up down, so they want to make the level of at least between the plants with the good level of organic materials. So they're taking this material from us. If not all of this, we take this material to damping area, because contain gravels, plastic, and so we cannot use it in our purpose.
All right. Thanks. Let me ask you about the plastic cover that you are using. How long do you use it for, and what is the purpose that you are using that? Let me give you a quick explain. This is the plastic cover is usually used on the first days when you have food waste and municipal waste, in a way of quickly accelerating the steep increase on the temperature of the piles on the first days of the thermophilic composting process. And that steep increase in temperatures conditions the microbes to eliminate the pathogens, and with even on the top layers of the compost.
And smell also maybe.
And in that process, you condition that you have only the thermophilic microbe community remaining, and then after that you can proceed without the cover. But I've seen that you're keeping cover for a long time. Can you explain that more for us?
Yes, actually, we use the Teptex cover. This is very important for us because, you know, we are in dry and hot environment, and also to keep the, you know, the interior or the environment of the compost window separate from the ambient temperature and from the wind and so on. We cover the window with the Teptex cover. It's called fleece or Teptex covers, to keep the moisture inside our compost in good level, and also to, you know, to allow the gas exchange between the window, because there's pores inside this micro for the plastic micro pores, we can say. We keep it this one because from our experience, when we don't apply this Teptex cover at least for 1 month, from 1 day to 30 days, this is the most important for us. We are losing moisture of the window, so the moisture easy to escape from the window because hot climate, you know. And the another purpose also to keep temperature, to maintain the temperature, especially temperature inside the window, especially at night, you know, still that the temperature maybe will go down. So we have to maintain or to keep the temperature of the window for 20 hours, you know, the same level. So this is the main purpose for using the Teptex cover. But after 1 month, we can say 1 month, 1 week after a month, we start to remove that Teptex cover. We use these Teptex covers, you know, one Teptex cover maybe will cover for 6 months or more than that, for 1 year, from 6 to 8 to 1 year. I mean the life of the Teptex cover, because, you know, this is still by running daily will destroy this Teptex cover.
All right. Last question from my side about the soil that you are using, the 10%, between 5 and 10%. Yes. Is it coming from the Al Hinai dam or any other dam that you want to mention?
No, it is not in Khord. It is in beside Barka. It is called Al Maawil dam, around for maybe 16 to 20 kilometers far away from our site. You know, we also we take the sediment, the top layer, maybe from 5 to 10 centimeter, which is the clay, because I think the clay deposit at the end of the, you know, the top layer of the deposition of the materials in the water when come to the dam. So we take that the top layer of the clay. We used before, it is called calcium bentonite. Calcium bentonite, this is the special soil. We brought it from India. It is also natural soil and totally clay, we can say. Here in our dam, it is not totally clay. You know, it still contains silt or you know, sand. So still, but the percentage, the top layer, it is, can say, clay. We stopped to use that calcium bentonite because, you know, it is expensive, and you know, the people in Royal Court Appeal want to save money, and actually we didn't find also different, because some places, I mean, one farm they said to us, when you use the calcium bentonite, the level of calcium inside your compost is high, and we cannot use your compost. So they prefer to use the compost without adding any, it's called calcium bentonite. So for that reason, we stop also to use this type of soil. So we are just using dam, clay dam. Why we use a clay for two main purpose? One for to moisture, or three we can say, not two. For the keep moisture, because clay absorb moisture, and also to provide what's called clay humus complex. This is actually, we tested, we found it, there's a humus when we add the clay, and also sometimes some microorganism with the clay, especially in the wet clay, we found some microorganism can add to our composting.
All right, just a few comments, and then we will close because it's time for the students to move for other lectures. Normally, when we do home composting, we recommend the use of soil as also as a source of inoculant. So yes. Soil in general, soils will have very diverse communities, including the thermophilic microbes, and it will increase the possibility of the diversity of the microbes that can grow during the different phases of composting. So as you add soil, that will also help in bringing a huge variety of harmless bacteria that will colonize this compost during all the phases, and will contribute for a swifter process during the composting process. So that's a very good thing. About the clay humus complex, the clays are organic matter stabilizers. So some of the organic matter that could have been lost by respiration will be stabilized by directly absorption, interaction, chelation with the clay matter. Nevertheless, as you said, the silt materials from the dams, they tend to be about only 20%, about 20% clays, 30% sand, fine sand, and 50% silt. And within the clay and silt material, you find that there is a lot of carbonates also, and the carbonates will have charge that can act the same way as a stabilizer of the compost. Last question: what is how do you estimate the percentage of the compost on the silt material, clay material, on the final compost product? Because 10% is when you add at the start, but it will be increased at the end. Do you think it will be 20, 30%? How much do you think there is the presence of this material on the final product?
You are good question, Victor. Actually, we found it that 10% that time is so high because there's a bad effect by adding clay to the composting. But you know that for two things. I mean, for the organic matter, we found that I found literature actually that if we add much clay to the compost, that reduced organic level of organic matter percentage, and also nitrogen, that also the final compost nitrogen will be less. So we started to reduce that amount. Why not use 25 to 5%, 2.5 to 5%? But still, you know, there is the debate. We found it should be, there is the quality, again, we found it different little bit. Estimation for the final clay, we didn't do it because when our compost, we found it not that much contain. Yes, sometimes sand, little bit of sand, I mean particles appears in, especially when we try to use the compost tea. When we start to use, you know, the compost tea, I did it by myself here in house to apply the compost tea. I found a little bit level of the you know, sandy soil inside our compost. And sand sandy soil is not coming just from the clay, even from the camel manure, the bedding of the camel manure there, they are using sand. So when they collect the manure, the sand comes with that manure. So again, we have from the camel manure, we have also sands. For the estimation, actually, we didn't do it at the, we can say, accurate level, but we found it is not that much. We can say acceptable. We didn't use how much the percentage in the total of compost, but we didn't find it, as a clear picture or something that significant to do it. It is very low.
All right, that's all from my side. Any of the students want to ask some questions to Ali before we leave?
No.
All right, then. So Ali, many thanks for joining us. It was great to have your presentation. I will share the video with the students so they can rewatch this and answer the quiz based on this presentation. And from your presentation also, some questions will be included on the exams. Thank you so much for coming. Really appreciate it. And we'll see you in the soil microbiology lab also.
Inshallah, anytime. I am happy to be with you. Thank you all.
All right, thank you so much. Thank you.
Thank you.
See you. Bye bye.
See you. Bye bye. Thank you.